As you have seen in the Faraday lecture videos, 5 compounds, sodium bromide, boric acid, copper chloride, lithium chloride, and potassium chloride, are all prepared in aqueous solutions. When sprayed into a flame, each compound will release a bright flash, changing the color of the flame. The color of each flame is produced by the electrons of each element becoming excited by the thermal energy of the flames. When they relax to their original energy levels, they release photons. The higher they jumped, the more energy the released photon will have. The photon will be released at a wavelength which is characteristic to the specific element, depending on its electronic structure. This produces different colors for each element. The device that is used to record a spectrum is called a spectrophotometer. It isolates the specimen so that only wavelengths from the material being observed are recorded. Light then passes through a lens and finds its way to a detector, which records the wavelengths on a computer. While this experiment is really interesting to look at, it also has some pretty advantageous applications. Because each element has a unique combination of wavelengths that it emits when it is excited, scientists have been able to identify exactly what makes up stars all across our galaxy by analyzing the light waves they emit. This means that they can identify what elements make up foreign solar systems without ever traveling there. With that knowledge, predictions can be made about which systems are most likely to support life. By measuring the intensity of the photons released by this experiment, we were able to determine how much energy was required to excite the electron to a higher state. This process is known as emission spectroscopy. We can combine this with other methods, like photoelectron spectroscopy, to determine how much energy is required to remove the electron from the atom completely, otherwise known as the ionization energy. Knowing the ionization energy of elements can help determine at what conditions a reaction will occur naturally.